Hello there and welcome back to our YouTube channel. Today we will be talking about Python and explore how to create diagrams such as bending moment, shear force and deflection. We will be using Python to make this happen, focusing on a simply supported beam of span L having point load P. I have divided this tutorial into two parts, theoretical and practical. In theoretical part, we learn some about formulas and different concepts, and then we apply the same concepts in the practical field by using Python. Firstly, let's see a free body diagram of simply supported beam. In this beam, point A and B are the supports, and in this beam, 15 kN load is acting at a distance of 3 meter from point A. The beam has a total span of 5 meter. Once I have created the Python file and executes it, Python generates this image. And our main task is to create the same image that you are seeing in the screen. Diagram for shear force, diagram for bending moment, and diagram for deflection. Before we dive into the coding part, let's learn some essential formulas for shear force, bending moment, and deflection. The formulas is very important in this matter. And I have divided our analysis into two sections, when x is less than a and when x is greater or equal to a. A is the distance between point load and one of its support A. Right now we are taking A as our reference, and x is the distance between point A and the point of interest where we want to calculate different forces. For each of these cases, we need to understand the respective formulas for shear force, bending moment, and deflection. The formula for shear force when x is less than a is equals to the reaction at point A, and when x is greater or equal to a, the formula will be negative times of reaction at R2. And it is very easy to calculate the reaction R1 and R2 by using some equilibrium equations and by taking moments at support. Talking about the moment, when x is less than a, the formula will be m equals to r1 times x. And when x is greater or equal to a, formula will be r1 times x minus p times x minus a. P is the force. Talking about deflection, the formula when x is less than a is shown in the screen, and when x is greater than or equal to a, you can see in the screen. Now let's learn some steps that we have to do in coding section. First, we have to import libraries, and we will import two libraries, NumPy and Matplotlib. NumPy is used for numerical and mathematical operations, whereas Matplotlib is used to generate informative plots and diagrams. After importing libraries, we take input from the user, such as load, span of beam, etc. And then we will use function named linspace. Linspace is an inbuilt function in Python NumPy libraries, and it is used to create an evenly spaced sequence in a specified interval. And the code looks like this. X equals np.linspace 0, L, 12. So let's elaborate a bit further because it is very important. Now I am taking a simply supported beam AB, and the argument in the code 0 means starting point of the beam. And the argument L means end point of the beam, which is also the span, and 12 means we are dividing that beam into 12 equal parts. So the code creates an array X with 12 equally spaced values starting from 0 and ending at L. We use this to create a set of X coordinates for plotting or numerical computations. Basically, we calculate force such as bending moment, shear force in each and every point that we have divided our beam. And after talking about function linspace, now we calculate the reactions by using different formulas that we have learned earlier, and we calculate the forces, moment, and shear, and then we plot our diagrams. For plotting the diagrams, we use plt.figure as a function, and plt refers to the matplotlib, which provides various functions for creating plots and figures. And plt.figure is a method used to create a figure or canvas to which we can add subplots. In our case, we will use this figure to house our three essential subplots for shear force, bending moment, and deflection. Like this: shear force, bending moment, and deflection. The first subplot is shear force, second is bending moment, and third is deflection. Now let's go to the Python and apply this all concept. Now let's dive into the main part. As I have told you earlier, we have to deal with two different types of libraries. One is NumPy and other is Matplotlib. So to import these libraries, we have to type import NumPy as CNP, import Matplotlib UIplot as PLT. So after importing these two libraries, now we have to take input. We have to deal with input parameters. So what are our input? Our input is load, length of beam, and position of load. So for the load, I am assigning variable as P. For the length of beam, I am assigning variable as L. And for the position of load, I am assigning variable as A. PLA. P means this load, L means total length of beam, and A means distance between load P and support A. So let's take this value, type float input load value in kilonewton, length section, type float put the length of meters, the position section, type float put the distance between load support A in meters. So this is our input parameters. Now if we see in this figure, when calculation of deflection, here is E and I. E means modulus of elasticity and I means moment of inertia. So let's calculate this. Calculation of E and I. The formula for E for the concrete section is 5000 root under FCK, and for the moment of inertia formula is BD cube by 12, means width to depth cube divided by 12. So let's calculate these values, and we are taking the section of beam as the width of beam is width of beam. Width of beam is 230 mm and depth of beam is 355 mm for the time being. So let's calculate E and I. The value of E equals to 5000 root under FCK. So right now I'm taking FCK value as 20 megapascal. FCK equals to 20 megapascal. I have to import math for using math. Okay, so this is the value for E, and let's calculate I, and I means 230 into 355 cube divided by 12. Now let's calculate EI. E times I times 10 to the power minus 9. Why 10 to the power minus 9? For the unit conversion. So in E and I, the units are in Newton and mm. But in the EI, I have converted that newtons and mm into kilonewton and meter. So for that reason, I have multiplied the value of EI into 10 to the power minus 9. Okay. So this is the value of our EI. So let's check once. EI in 5 2. Okay, the value of EI is 19174.173. which is right. Now we will calculate reaction at supports R1 and R2. Calculation of reaction R1 and R2. So we have formula for this. R1 is equals to P times B divided by total length, whereas R2 is equals to P times A divided by total length. So we have all the values for the calculation of R1 and R2 except B. For B equals to L minus A. So R1 equals to P times B divided by L, where R2 equals to P times A divided by total length. Now we are done with calculation of reaction. Now we use the function lean space to divide the length of our beam. So let's type x equals to np dot lean space 0 comma L comma 200. So right now we are dividing our beam into 200 equal segment. Now we are calculating our shear force, bending moment, and deflection. For the calculation of shear force, type V, and I am assigning V as a variable for shear force. V equals to np dot lean space 0 comma 0 comma 200. So which means we are setting the value of V, or the value of shear force, to be 0 for each of the 200 point initially, and after that we calculate using the formula of shear force and we override that values. So for the calculation of shear force we use the formula this. When x is less than A, our shear force value will be the reaction at support A, and when x is greater or equal to A, our shear force value will be negative of the reaction at support B. Now we type this value. So V when x is less than A, and this Vx is less than A is the conditional index. It selects the element in the array V. V is the array where the corresponding element in the array X are less than A. Okay, so let's type the formula over here. Vx is less than A equals to R1, and V when X is greater or equal to A. And what's the formula for this? Minus R2. So we are done with calculation of shear force. Let's check shear force. Let's give 15, 5 and 2. Okay, we have 200 values over here of V. Now let's calculate bending moment. Calculation of bending moment. We use the same expression over here. We copy here. We change M instead of V. So it also means we are setting the value of moment to be 0 for 200 points, for each 200 points that we have divided. So right now we are writing the formulas for moment. When x is less than A, the formula for moment is R1 times x equals to R1 times x when x is less than A. The formula is very simple. So when x is greater or equal to A, when greater or equal to A, the formula is R1 times x, right? R1 times x when x is greater or equal to A minus P times x minus A. So instead of x, we have to type x greater or equal to A. This expression. Okay, so we are done with moment also. So let's check the moment values. print yum. Let's see. Let's type load again. 15 5 2. Okay, this is our movement value. At point 0 our movement is 0, and at last point our movement is 0, which is the case of simply supported beam, right? We are done with movement also. Now we will calculate our deflection. Calculation of deflection. So for deflection also we use the same expression, just with slightly modification. Like we write d, we assign d variable as a deflection. We have to write now formula, and when x is less than a, we write this formula: pbx divided by 6ei l square minus p square minus x square. So when x is when d when x is less than a, our value will be p times x is less than a divided by 6 times ei times l into l square minus p square minus x less than a square. Okay, now when x is greater than or equal to a, the deflection formula will be this: p times a times l minus x is greater or equal to a divided by 6 times ei to l. 6 times ei into l into 2 times l times x greater or equal to a minus x greater or equal to a square minus a square. Here b. So this is the case for deflection. After the calculation of shear force, bending moment and deflection, now we have to plot those forces in diagram. For that we use function, and the function is type fig equals to plt dot figure, figure, and the plt refers to the Matplotlib, and Matplotlib is a library that we have imported earlier, and plt dot figure is a method which is used to create a new figure. So right now we have created new figure, and the new figure is assigned to fig. Now we have to add 3 subplot for the shear force, bending moment and deflection, and we have to define the axis also. So ax ex axis, 1 for shear force, 2 for bending moment, and 3 for deflection. So let's write the code. ax1 means first axis equals to fig dot add subplot add subplot 311. What is mean by 311? So right now we have added first subplot, and the argument 311, the 3 means the number of rows, 1 means the number of column, and other last one means, or it indicates that we are currently adding the first subplot in this grid. Now let's add the title for our figure, plt.title title, and this is our shear force diagram. Now we repeat the same thing with certain modification and adjustment. Let's see, axis 2 and subplot 312, and this is for bending moment diagram. Just repeat the same thing once again. Axis 3 and subplot is 313, is for deflection diagram. Deflection diagram. Now we have to plot, and for the plotting, type ax1 dot plot x comma v. V is for shear force. Now once again repeat the same, ax2 dot plot x comma m is for bending moment, and ax3 dot plot x comma minus d, which is for deflection. We can also change the color of the plot, but now for the time being, just we go for this, and we have to use, and then we have to adjust the figure also. The figure dot, for the adjusting of the figure, type figure dot height layout, and then at last plt dot show. Save, and we will run this. Let's take load value as 100 kilonewton. Let's take 20 meters beam, and let's take 5 meters. Now we have the diagram: shear force diagram, bending moment diagram, and deflection diagram. Now we can use this code as many times as we like. First we have to input the values and get the output results. Let's check once again. The load is, let's assume 100 kilonewton. The length of beam is 10 meters, and enter the distance between load and support, means a value, which is, let's take at the middle of the section of the beam, and this is our diagram. It is in the middle of the beam. Shear force diagram, bending moment diagram, and deflection diagram. So in summary, we first import different types of libraries like NumPy and Matplotlib, and then we input our parameters such as length of beam, loads, and then we use function called linspace to divide our beams into several parts, and then we calculate our reactions and different types of forces such as bending moment, shear force, and deflection, and then we plot our diagram. In the next part, I will use different loops and celluloid model to create animation of those figures. So stay tuned. Thank you for your attention.